The next one is another example. We can connect these small-scale observations to a larger scale. So this is showing a view to the southeast, and we can zoom in and see the kind of detailed features in our landing site. The rocks here have a very blocky texture. Just as a reminder, Phoenix landed in an area that was affected by the impact that created Heimdall crater, and you're seeing relatively smaller rocks, rocks up to ballpark of a foot across. We're not seeing the large boulders that we saw at other places that caused us not to land there. The rock in the right-hand side there, Toto, is very interesting to me with its flat top, sort of an icebergy appearance, although it is a rock. And then as we pan out, we get to connect to the site as a whole. This is where we start seeing some of the troughs. We see the rocks just perched on top of the surface there. And going further and further out, we're still seeing mostly smaller rocks mixed in with the polygons until we get to the greatest distances where we can see the horizon. We start seeing two larger boulders there. Essentially, we expected to see boulders of the meter-plus scale, about one per baseball field in terms of size. And then at the far upper right-hand side, you see a bright glint. That is actually the back shell. You see the gold foil on the inside of the back shell that helped us land here. One interesting thing about that is if you look at the back shell closely, there is no parachute visible. While the parachute is clearly visible from orbit, the parachute must be lying in one of the troughs and hidden from our view. It'll be interesting to see if the wind blows it around any, if it ever shows up from our point of view. The next panorama I want to show is part of a complete set that we're trying to take. Ultimately, we will have a 360-degree view of our site in full color and using our binocular vision, using both eyes of SSI. This one is particularly important because this section, which was taken in the evening of Sol 14, actually comes up near our workspace. So you're looking essentially 10 feet away from the lander right now, just beyond Humpty Dumpty National Park. And as we pan across, we'll actually be coming up onto the area just behind Humpty Dumpty itself. Right now, we actually started just past where the trench is. And then as we go down, or as we continue to go across, we'll get into an area which connects up with Sleepy Hollow. So we're connecting the polygons and the troughs that we're seeing in the broader site with the ones in our immediate workspace. So I want you to imagine now standing, crouching in this area that we're looking at. One of the things that we can do with SSI is not only take color images, we can take stereo images. We take advantage of the camera's binocular vision, and we can use our depth perception to model the landscape. So the next graphic shows the landscape modeled. Right now it's only in black and white, but it shows this small section of Mars, and we're actually crouching down where we were just looking before in the color panorama and kind of turning our head around. You can see some of the polygons and troughs, the little hilly texture that you see. These are only about 8 inches tall, but if you sort of imagine yourself crouched down, they start to look a little more dramatic and impressive. I think this view is excellent. This is the sort of thing that we're trying to build up for the whole site. By the next week or two, we should have completed our mission success panorama, the panorama that we want to take to show from the spacecraft out to the horizon in full color and stereo, so that we can show an image like this only in color and fly around the entire landing site. So that's something that we're about halfway done with right now. We started on Sol 13, and through about Sol 18, we're about halfway done. So now, the last thing I want to mention that SSI does, we've been spending a lot of time looking up at the sky. SSI helps with the weather monitoring. There's a lot of dust on Mars, and we're measuring the amount of dust in the sky, and we're measuring the winds and seeing how the winds are blowing the dust around. And to talk more about the weather and how we're looking at it, here is Nilton.
Thank you, Mark. Phoenix is also studying then the weather and the climate in the polar region of Mars. And in order to do this, Phoenix has a meteorology station and a LiDAR that were built by the Canadian Space Agency. It has a mass spectrometer that's being used to measure the composition of the atmosphere. And it has 2 cameras that are going to be looking at the atmosphere and around near the surface. And it has a few other instruments, including the microscope that Tom Pike talked about. with the microscope, we'll look at the dust particles, including the particles that are raining out from the atmosphere. And can I have the first slide? So in the first slide, we have, for example, the weather report from yesterday. The temperature at the landing site has been between minus 30 degrees Celsius and minus 85 degrees Celsius. So it's really cold compared to the Earth, even the Earth polar regions. The pressure is very small. Like yesterday was 8.35 millibars. On Earth is 1,000 millibars. So it's a very small fraction of what we have on Earth. And the wind in the landing site has been pretty calm. Like yesterday was 14 kilometers per hour or 8.7 miles per hour. And we haven't been seeing too much in the action in terms of dust storms. But there is lots of dust in the atmosphere. And in fact, the atmosphere of Mars at the landing site has been like a really polluted place on Earth with lots of fine in the air. So decreasing the amount of solar radiation reaching the surface by about 10%. Can I have the next slide? So in the next slide, we show a little dust storm downwind of the landing site. Okay, this one shows 3 big dust storms over more or less the place where we landed. And those are very common both at the beginning of the spring and at the end, towards the end of the fall. So we expect to see some of those at the landing site, hopefully at the end of the mission. Some of us will be very excited about making measurements in those conditions. And the amount of dust will be so much that the surface can get really dark. Less than 10% of solar radiation might reach the surface. So, and I have one more slide. Okay, this one is showing a regional dust storm. We have been seeing lots of those, and it's close to a really deep valley in the ice there that's 3 kilometers deep. So it's the cold air rushing down this canyon and lifting dust downwind of Earth. And that dust is swirling around and moving around the planet. And where we landed is quite safe because it's upwind of this region. So all this dust is moving away from the polar cap and away from the lander. And as you can see, really around the polar cap is very windy. The dark areas that we see there are sand dunes. So there's lots of sand dunes around the polar cap. So I have one final slide too. Okay, this one was made by Mark Lemon with the camera. And it shows on the left is just the background sky that you can see sort of dust when we look vertically with the camera. And the one on the right is a stretch version, and also its difference between sequence of images, and show us the dust moving with the wind. So we haven't been seeing any big dust storm, but we have seen lots of dust moving with the wind. So it's regions of more or less dust content moving, like what you would see outside in Tucson at this time of the year. Now to finish talking about the weather, what's really important is that in atmospheric science we cannot do controlled lab experiment to test theories and our understanding of our own atmosphere. But we can go to other planets like Mars and make measurements there and test the theories that we have that are sort of tuned with our bias towards what we understand of the Earth's atmosphere. So it's really important to go to other planets, especially Mars, that has a much simpler atmosphere without too much clouds and without ocean. And another really good thing about Mars is that there's lots of dust in the atmosphere there, and we don't understand how dust gets from the air into the atmosphere and how it interacts with climate. In fact, this is responsible for one of the largest uncertainty in global climate prediction today. So we are going to learn a lot with this mission. I'm really excited to be part of it.
Okay, thank you, Nelton and panel. We're going to go to questions. We're going to start here in the theater. Please wait for the microphone and say your name and your organization.